The point A has coordinates minus 3, 4, and the point C has coordinates 5, 2. The midpoint of AC is M. The line L is the perpendicular bisector of AC. Find an equation of L. Find the exact length of AC. The point B lies on L. The area of triangle ABC is 17 root 2. Find the exact length of BM. Find the exact length of AB. Find the coordinates of each of the two possible positions of B. Okay, so here's the question then in summary form. So the midpoint we better get of AC first of all is M is mentioned. So M as a midpoint, add them up, minus 3 and 5. 5 take 3 is 2, divided by 2 is 1. 4 plus 2 is 6, 6 divided by 2 is 3. So there's the coordinates of M. L is the perpendicular bisector of AC. So I'm going to draw a little sketch for that. A is, just mark off A, minus 3, 4, and C is 5, 2. Minus 3, 4, and C is 5, 2. There's C, 5, 2, and A is minus 3, 4. So we've got our line AC, and then M is the midpoint. Okay, and line L is the perpendicular bisector of AC, so it goes through the midpoint M, doesn't it? Like so. So there's our picture for illustrative purposes. Okay, good. So that's what we've got then. So part A, find an equation of L. So the gradient of AC, we need the gradient, this is perpendicular. So if we get this gradient, we'll find that gradient, won't we? So gradient AC then. The increase in y is 2 take 4 is minus 2 over the increase in x. 5 take away minus 3 is 5 plus 3 is 8. So that gradient is minus a quarter, negative shallow, which is what we expected. So the equation of the line L then, it goes through the point M. So y minus the y value is equal to the gradient of the normal here. This is the other gradient. This isn't a normal, this is perpendicular. So the gradient is 4 x minus the x value of M. So here y is equal to 4x minus 4 plus 3 is minus 1. So there's our gradient of L, the equation of the line L, which we've done there. Find the length AC. So AC then, using Pythag, this would be B. So that was A. B now, the length AC. Length AC is equal to, use Pythag. It's a triangle, isn't it, here, in our mind's eye. So the horizontal distance between the x's is minus 3 to 5 is 8. 8 squared is 64. Vertically, it goes up from 2 up to 4. 2 squared is 4. So it's root 68. And that's 4 times 17, so that's 2 root 17 when we simplify it. There's a 4 here, 2 34s, and then it's 4 17s. Root 4, root 17, root 4 is 2. So there's length AC. So that length AC is equal to 2 root 17. Okay, we've done length AC then. So B lies on L, so I'm going to mark it here. There's B, say. The area of ABC is, I think this should say 17 root 2, which I forgot to write down. So I'll put it down now. That's from memory. I'm sure it's right, because I remember it when reading the question. So this area is 17 root 2. We know this length here, so half base times height could give us the area. So, and that will help to get the height, won't it? So here for part C, here, half base, half of this length, which is 2 root 17, times the height, which is the length of BM, is equal to the area. Half base times height is the area, which is 17 root 2. So the 2's cancel, and then we can see that the BM then, that length, will be equal to, well, the 17, root 17 comes down, and one of the root 17 goes from here, so we'll have root 17 times root 2 is root 34. Type it in the calculator if you need to, just move this down and simplify the surds, and you get root 34. So there's BM. Find the length AB. This length here, this is a right angled triangle. We know this length here is root 34. We know this length because it's just half of this length, isn't it? So this is root 17. So we can now work out this length here, AB. So length AB is equal to, use Pythag, this squared plus the square root of the other two sides squared and added. Root 17 squared is 17. Root 34 squared is just 34. 34 plus 17 is root 51. That's length AB. So this length here then is root 51 in the picture. Find the coordinates of each of the two possible positions of B. So B is here. We know it's on this line here. And we know this distance here is root 34. B has coordinates, because it lies on the line L, of, we'll use a parameter t, and then because it's lying on this, and this is the normal line L, equation of line L, it'll be 4t minus 1. So the difference between M is the coordinate 1, 3, isn't it? So again, using the property of the triangle, the distance BM, this squared, so 34 then. So 34 is equal to, so this side of the triangle squared is 34, t minus 1 squared, doesn't matter which way around you write it, it's just a difference squared, and then 4t minus 1 take 3 is 4t minus 4 squared. Let's just check that again then, this one here. What were we doing? A 34 was this length here, and then we imagine a triangle between the coordinates. So the difference here is t minus 1, so we can write that as squared. And the difference here is 4t minus 1 take 3 is 4t minus 4 then, and just square that difference here. So this will be equal to then, there's a t minus 1 squared here, there's a t minus 1 here with a 4. Take the 4 out and it's 4 squared. So it's 4 squared is 16 plus one of them is 17 times t minus 1 squared. So that tells us then that t minus 1 squared is equal to, move the 17 from times to divide, 34 over 17 is 2. So t is equal to square root, so on square root this, that, and you get root 2. Plus or minus, and you get t minus 1 here, but move the 1 over, and we get t equals 1 plus or minus root 2. These are the two possible positions. Find the coordinates of each of the two possible positions of B. So here B has coordinates 1 minus root 2, and then something else, or B has coordinates 1 plus root 2. Now the y value at B is 4t minus 1. Here it is here. 4t minus 1. So it's 4, 1 minus root 2. And this one here is 4. Oh, hang on. 4t minus 1. 4t minus 1. Or 4t minus 1 there, i.e. B is 1 minus root 2. 4 minus 1 is 3 minus 4 root 2. Or B, 1 plus root 2. And 4 minus 1 is 3 plus 4 root 2. And there's our possible two coordinates for the point B. Yep,